Hello everyone. All right, we are continuing on with our discussion of measuring angles. We are going to look at measuring angles with a protractor. Okay, here we have a protractor. A protractor is a tool that we use to actually measure angles. All right, typically you'll find a piece of plastic in a store for about $1. That's all it takes for a protractor. You can print one off on paper and use it. All right. This is a tool to measure angles. You'll notice that there are two tracks. Angles, again, are measured in degrees, so this represents 0 degrees here. Following along the inside track, we come around to 90 degrees, continue around, and we end up at 180 degrees. You'll recognize this shape, entire shape, as a semicircle. All right. On the outside track, it is the same scale. It starts at 0 here, goes past 90 degrees, and ends at 180 degrees over here. What is the benefit of having the scale written 2 times? It depends on the orientation of the angles. All right, some angles may open this way as you go to measure them. Some angles open this way as you go to measure them. So this just gives you flexibility when measuring the angle. All right, so let's see how this works. Okay, we have the protractor postulate, and don't forget a postulate is a statement that we assume to be true. All right, so again, the numbering system was established for us, 0 to 180 degrees, so we are going to work with that. And it says that for every ray that is formed, all right, each of these rays pairs with exactly one number. So this ray pairs at 0, ray AO is pairing over here, and this is how we are able to determine the interior measure of this angle. Okay, let's see a real live example. All right, so in this example, I have the angle AOB. B has the real number 0 assigned to it. It runs up this way. All right. Ray AO stops at 125. Therefore, I know that the measure of angle AOB, the interior part of this angle, is 125 degrees. All right, sometimes we're going to need the absolute value. All right, this is similar to what we were doing with segment length. Anytime we're talking about measure, length, distance, it is always positive. It is not positive or is not possible to have a negative value for an angle. Okay? All right, so let's look at this formula here. All right, and when do we need to consider that we might have to use absolute value? Well, look at the orientation of this angle right here. All right, in no place is it starting at 0. All right, so I'm going to have to do some subtraction here because I am focusing on the interior of the angle that is in pink here. So let's see how we're going to measure that. Okay, so here's my formula, the absolute value of C minus D. All right, C I see at 135 degrees. D I see at 35 degrees. Okay, I take 135, I subtract it from 35, that gives me 100. It's already a positive number, so I will leave it at that. Therefore, the measure of angle COD is 100 degrees. All right, practice problem for you. Here are your questions. What is the measure of NKL? What is the measure of NKL? And also, what would that classification be? Acute, right, obtuse, or straight? Please stop this recording now, determine your answers, and then move on to the final slide. Okay, What is the measure of NKL? Well, N starts at 0, so I simply need to follow this inside track up here, and I see that it stops at 145. Therefore, the measure is 145 degrees. The measure of NKL is 145 degrees, and according to our classification, that makes NKL an obtuse angle. Alright guys, you're welcome to watch this video as many times as you need. There are a few short questions that follow this just to check that you were paying attention. We'll discuss this in class this week. Have a great week.